Real life of a CNC machine operator. In this video I show what a CNC machine operator has to do during his average day. You may want to read the text in the author's box for more information. The main item of college propaganda was the story that CNC programming is practically a desk job. In reality, there is so little programming in an average CNC shop that the only programming one can hope to do would be on top of his duties as a machine operator. In this video I show what it involves. Let me start here with the initial shock I have got after I started working. Soon after I started my CNC job, we had an order of several thousand small parts. We had to machine them on a lathe. The length of a cycle was 15 seconds. I was doing that order. 2 parts per minute, and like that for a whole day. It's not even a laborer's job, it's a robot's job. I really thought I would lose my mind. And after that I knew that CNC is definitely not for me. In view of this reality, I started looking for another job, but could not find anything suitable. I was 50 at that time. I then moved to a saw, even though I continued operating CNC machines mostly when the full-time operators were on breaks. I was also doing other tasks around the shop, such as operating manual machines, deburring, carpentry work. Carpentry is a very good example of a creative work, as compared to a repetitive, monotonous one. If there was an opportunity to stay after hours with a carpentry task, I would always stay, and it had very positive effects on me. The main job of a CNC machine operator is to change parts. This involves operating an air gun, foot switch, taking the finished parts out, putting the new ones in, overall doing half-dozen moves per every part. While the machining cycle is going, the mill operator is breaking the sharp edges on the finished parts with special tools. It is called deburring. Operator may also be running 2 machines at the same time. It is a routine thing in this business. Operator can also perform additional operations on a drill press or a manual mill. For example, countersinking or counterboring holes. The operator has to change parts at a fast pace, very fast pace. On a lathe, you are expected to hold the part and the air gun in the same hand. You can see on these pictures how it is done. Obviously, these rules can only be followed when the parts are rather small. Here you can see a work table of a lathe operator. He has to keep track of dimensions of the finished parts, which means taking irregular measurements and to adjust offsets if required. 3 micrometers and a caliper certainly look like an impressive array of precision measuring instruments, but it doesn't change the reality that the operator of that lathe is going through the same series of movements for every part. Operators may have to use dimensional gauges, go and no-go, thread gauges, but they do not have to do deburring as on a mill. Here you can see a machine to sharpen the cutters. Every operator has to use it on a regular basis to keep the cutters sharp. Here I am cutting plastic sleeves to protect the threads on the finished parts. And I then lay those parts out in rows on a pallet and sprinkle them with rust protection oil. Sometimes cutters break, but the machine of course continues working. The operator has to check for broken tools at the end of each cycle. He takes the last part and checks it, in particular all holes and all threads. If any is not there, this means the tool was broken, a cutter. In that case, you have to start checking the other parts, from the last to the first, till you find the one where the tool broke. We had a case when one operator had failed to promptly notice that a tap was broken and had gone through several cycles with a broken tap. The hole was drilled, but there was no tap to cut the thread. Later he had to spend half a day cutting threads in those holes in a manual mill. Soon after that he was let go. Sometimes the saw does not produce a straight cut, but the material can nevertheless be usable. The saw operator marks it, and the mill operator has to keep an eye for such markings and to position the material appropriately. Plastics can also be machined on both lathe and a mill. You can see on this picture a cart with plastic parts. It takes more effort to machine plastics since the conveyor cannot be used to remove the chips. Even if a particular plastic is heavier than water, the chips are still not dense enough to allow a safe operation of the coolant filter, and it will quickly plug up. That is why the operator has to keep the conveyor off and to use a shop vac a few times an hour to remove the chips. He then dumps those chips into a garbage bin and takes it out into a garbage dumpster. Here I am rinsing the mill from inside to wash away the metal chips. On the next picture, another operator is doing the same. You have to do it every time when switching to a valuable metal, such as aluminum, bronze, brass, stainless steel. There should be no contamination of valuable metals. Otherwise the recycler may reject the entire batch. Every machine has a hose just for this purpose. On other pictures you can see that lots of very small chips can get stuck to the inner partitions and other parts inside the machine. Since CNC mills are open from the top, chips fly over the vertical partitions on all sides, and they fall to the area where the worm gear shaft and the gantry rails are located. This is a critical area and has to be kept clean to make sure that nothing would interfere with machine movements, which would affect accuracy. That is why cleaning of that area is an important duty of a CNC mill operator. He vacuums it on a regular basis. On some jobs, which produce lots of chips, he may well have to do it several times per shift. A shop vac is always in use in a CNC shop. The operator has to sweep the area around the mill, since the chips are flying over the partitions. If a shop vac was used to remove metal chips, it is emptied into a steel bin. Its hose is always full of oil and has to be drained frequently. Leaving it on the floor can produce a big puddle of oil. Shop vac filter has to be replaced on a regular basis. However, this procedure is more likely to be done by general help in a shop. If the coolant filter gets plugged, the coolant will be flowing over. This is a big emergency. The operator has to remove the obstruction as fast as possible and to mop up the leaks. If a particular day is very hectic, he can ask general helpers to clean the floor. Sometimes there can be very big leaks. General helps will have to deal with those. The operator has to keep an eye on a device which collects oil from a coolant. It consists of a disc which rotates in a coolant tank and a squeegee. This oil is produced when the rust protection is washed away during machining. It also contains lubricating oil, solidified components of a coolant oil. As in any device, there could be malfunctions in a coolant circulation system. We had at least one case when a faulty valve had to be replaced. This series of pictures shows the most unpleasant duty of a machine operator, cleaning the coolant filters. Here you can see a lathe filter. Again, most likely this task will be delegated to the general help. It is a very big job and it may take half a day. A thorough cleaning is done about twice a year. That includes dumping the coolant oil and cleaning the insides of a settlement tank. The filtering system may well require emergency service several times a week to scrape the chips off the horizontal grill. Chips on that grill interfere with the flow of coolant, which results in spills. An important part of cleaning the coolant filtering system consists of washing the container and the filter grills to remove the solidified residue of oil. It is very time consuming and requires plenty of effort, as you have to practically crawl all over that coolant filter. You can see on these pictures how the coolant filtering system on a mill is cleaned. It is a very big and unpleasant task, and the mill operator may well have to do it. Washing the coolant container on a saw is much easier by comparison. Used oil is dumped into a waste oil collection tank. Washing the insides of a machine is another big and unpleasant task. All those partitions and other parts. Over a course of a few weeks, plenty of solidified coolant oil can settle on those. Washing is done with solvent or industrial cleaner. On several occasions I was observing the mill operator spending several hours on it. Washing the footboards is another thing operators have to do on a regular basis. The rubber mats over the footboard are from the lathe area. The operator there prefers those over footboards. Rubber mats are not used in a mill as they would be quickly covered with chips. Machine panels also have to be washed regularly. A lathe can cut parts from a bar. It is called a screw mode. A parts catcher is deployed at the end of a cycle. However, the finished part may miss it and fall on a conveyor and end up deep inside the drum. To prevent this from happening, the operator has to frequently spread the chips inside the drum, leaving no gaps. I'm showing how it is done, even though of course you do not do it on a mill. Here you can see the output point of a mill conveyor. I have never seen it jamming, but it jams quite often on a lathe, because it produces long and curly strands of metal, which can easily be dragged around the conveyor till it will eventually jam. A lathe operator has to constantly keep an eye on a conveyor and to break the entangled strands with special hooks. Drums with disposable metal are emptied into a steel bin. Drums with valuable metal are taken to a designated location to wait for a recycler's truck. There is a separate video which shows how much heavy lifting one has to do in a machine shop. Overall, the operator is responsible for all aspects of running the machine and maintaining it in a good working order. And of course, he would be expected to have enough understanding of things mechanical to be able to reconnect from one compressor to another, to replace air filters, an air gun nozzle, plus to do many other things. As one can well imagine, a person who had never been in a machine shop would have no clue as to how they operate, and what is the range of duties of a machine operator. Now you know, and you can make an informed decision of whether or not you may want to try the profession of CNC machining. Thanks for watching. More interesting and useful videos will be coming on a variety of different subjects. You may want to subscribe not to miss any new releases.